Hello students, today we will discuss some of the questions regarding the nature of the matter, what all things are happening in the matter, what all effects we are seeing in the matter when we change their conditions like temperature, pressure, volume, etc. So here is the question number 1. It has been found that carbon dioxide is heavier than oxygen and nitrogen. Gases which are present in the air, but it does not form the lower layer of the atmosphere. Why? It doesn't form the lower layer of atmosphere. Why? The question is asking carbon dioxide, which is a gas, it is heavier as compared to the oxygen and the nitrogen gas which is present in the air. But being its heaviness, it doesn't form the lower layer in the atmosphere. What's the reason behind it? The reason is all these are what gases. Gases possess the property of diffusion. They have the property to diffuse, that means the intermixing of the particles, which is independent of the force of gravitation. Gases possesses property of diffusion, and this diffusion property is further independent of force of gravitation. So due to the diffusion, the gases mix to each other and remains almost uniformly distributed in the atmosphere. That's why carbon dioxide, though heavier than oxygen and the nitrogen, but it doesn't form the lower layer in the atmosphere because it is independent of the force of gravitation, and due to the property of diffusion, diffusion means what? Intermixing of the particles. They mix to each other and remains almost uniformly distributed. Second question is why vegetables are cooked with difficulty at hill station. What is the answer of this question? The answer is at hill station the atmospheric pressure. The standard atmospheric pressure is what? 1 bar, which is less, so the boiling point gets lowered. The atmospheric pressure is less, and so the boiling point. That's why vegetables are cooked with difficulty at the hill station. Third question is why falling liquid drops are spherical? Why the falling liquid drops are spherical in shape? So what's the reason behind this question? This is due to the property. The liquid drops are spherical in shape because liquid possesses the property of surface tension, and this surface tension property, it makes the surface area minimum. For a given volume, sphere has the minimum surface area. Spherical property, sphericalness of the liquid drop is due to property, that is surface tension, which is exerted by the liquids or possessed by the liquids. This surface tension makes the surface area minimum. Thus, for a given volume, if we have a known volume, if the volume is given to us, the sphere has minimum surface area. So the liquid drops are spherical in shape. Next question is, if a liquid is transferred from a smaller vessel to a bigger vessel at the same temperature, what will be the effect on the vapor pressure? If we are taking a liquid, if the liquid is transferred, suppose this is a smaller vessel, it contains a liquid, and this liquid is transferred to a bigger vessel. Now what will happen? This transfer occurs at same temperature. Temperature is same. Now what will be the effect on the vapor pressure? What will be the effect on vapor pressure? If we are transferring a liquid from the smaller vessel to a bigger vessel at the same temperature, then what effect is seen on the same temperature? Then what effect will be seen onto the pressure? No effect, as it depends only on the nature of the liquid and the temperature. Does the pressure gets affected? No. No effect will be seen because it depends upon the nature of the liquid and the temperature. It depends only on nature of liquid and temperature. Now the next question is, what do you understand by the term gas and the vapor? What is the difference between gas and vapor? Answer is substance which is in the gaseous state. If a substance, suppose we say water, if this water exists in the gaseous state at room temperature, then we'll say it as a gas. If a substance is not in the gaseous state at the room temperature, but it changes into the gaseous state on heating, just as suppose this is a substance, water is a substance which is not in a gaseous state at room temperature. This is liquid at room temperature, but this liquid state of water gets converted into gaseous state on heating. Then the gaseous state which is obtained is called as a vapor. This particular state is termed as vapor, or we can say when a gas is below its critical temperature. When a gas is below its critical temperature, then it is termed to be in its vapor. Next question. What is the difference between the normal boiling point and the standard boiling point? Difference between normal boiling point and the standard boiling point: when the external pressure is equal to 1 atmospheric pressure, the outside pressure, that is external pressure, is equal to 1 atmospheric pressure, then at that particular point of time the boiling point is referred to as a normal boiling point. When external pressure is equal to the 1 atmospheric pressure, and when the external pressure is 1 bar, is equal to 1 bar, then it is called its standard boiling point. The next question is, what happens if a liquid is heated to a critical temperature of its vapor? If a liquid is heated to a critical temperature of its vapors. What is the answer of this question? The question is asking, if we are heating a liquid to a critical temperature of its vapor, then what will be going to happen? The answer to this solution is the meniscus between the liquid and the vapor gets disappear. What will be the meniscus is between the liquid and the vapor. Liquid and vapor, it gets disappear. So the surface tension of the liquid becomes what? 0. Surface tension of liquid becomes 0. Now the next question is, N2O and the CO2 have the same rate of diffusion and the same condition of temperature and pressure. Why? N2O and CO2, both the gases have same rate of diffusion. What's the reason behind it? And they have same rate of diffusion under same temperature and pressure. Why? What's the reason behind it? Answer will be, we know that rate of diffusion is what? Rate of diffusion is a condition which is inversely proportional to the square root of the molecular mass of the gas. Now, if we focus onto the molecular mass of N2O and CO2, the molecular mass of N2O, which comes out to be 14 multiplied by 2 plus 16, which is equal to 44, and the molecular mass of CO2 is equal to again what? 12 multiplied by 2, 12 plus 2 multiplied by 16, which is again equal to 44 grams. So if we calculate the rate of diffusion of N2O with respect to CO2, it will be what? Molecular mass of CO2 by molecular mass of N2O, which is found to be same. So thus we can say that, and according to the Gram-Stokes diffusion, the rate of diffusion of different gases are inversely proportional to the square root of their molar masses and the same condition of temperature and pressure. That means they will have same rate of diffusion under same condition of the temperature and pressure.